Всем привет! У нас начинается новый мастер-класс.
Hello everyone, we are about to start a new workshop. Maksim Milyutin, Patroni and Stolon installation, fine-tuning, and working with crashes. Hello everyone, can you hear me? Everyone can hear me? My name is Maksim Milyutin. Currently I'm working at an Ozon company. I'm working mostly with the development, but in the past, I was in the technical support, and I worked with the cluster solution, Patroni and Stolon. I would like to share my experience with you today. A little bit about the plan of this workshop, and I will try to set the components from scratch, and Stolon and Patroni step by step, and then also we are going to look at some fails. All the installation they were done according to the experimental playbook and roles that we were developing in the PostgreSQL to experiment with cluster and to offer them to customers. But if you want to, for example, to install Patroni, a cluster that will be fully ready, then I can recommend you certain playbooks that were developed by Vitaly Kuhorik. Until recently, they were quite popular in the Russian-speaking community. Well, let's start with some technical part, with the introduction. So all the high available clusters on PostgreSQL basis, so they are used without the division of the data. Just to compare, for those who came from the Oracle community, there is a cluster log, and these are clusters with the shared disk. And clusters they're not built on the PostgreSQL and this architecture, and all of them are built on the physical replication. On the replication where we have migrating the changes of the page, physical changes in the pages from masters to replicas. The host standby is also supported, and we also have a well-proved tool to manage the nodes. Best backup, the possibility to make a backup, to do a backup from master to replica without breaking up the workload. We can promote the node from the standby mode to master. There is also good utility that allows you to bring it back from master to the standby mode, and to monitoring two tools that are showing the current slots of replications and statuses of all the replicas. After the version 10.0, we added PostLogic application, and it's a good thing to have cluster solutions on that basis, at least to bring down the traffic of the replication. Because as is well known, the logical changes, they are manifold smaller than the changes at the pages level. And it's not only because of the replication about these changes, because they are distributed apart from the data files to all the indexes, but also that the wall is also working with the full page images, the full image of the page after the checkpoint. It also covered the changes in hint bits and so on and so forth. So, of course, it increases the traffic manifold. And Uber and its time and their famous article, Migrating to MySQL, they were talking about this physical replication, but building clusters on the analogical replication, there are certain limitations, certain restrictions, and it's not the cause is not only that the analog replication is restricted by certain positions, but if we have the reposition of replica to the new master, then this replica must be uploaded, so because the replication position is tied to the physical wall position, and it's developed in different ways in each node. So there are a lot of analogs, CSN, context novo in MSQL, and there is no an analog for Carivine. But the cluster solutions in Patroni, they want to add the support of the logical application to be able to roll up the upgrades without any downtimes. So how could we present a primitive auto-failover when we have masters and replicas? We can put arbiter a third service up there who would check the hosts of the nodes and also will send some managing signals. And if the master is failing, then this arbiter could do the simplest thing. It can send a promote signal of the replica, and it would then go to the master version. But this architecture is really unstable, and what will happen if the master will become isolated? Then you will have that the signal will reach the replica will become master, and then we will have two masters. And it might be okay, but we can do the split brain with two conditions. If the former master, we also have some clients, and if we have asynchronous replication working, and in this case, all the connections are coming to the former master, they will crash because they are going to wait for the approval from the replicas. I can explain you how to deal with it, but a little bit later. How can we deal with this case? Above Postgres, we can implement special agents that would manage our Postgres nodes. And apart from communicating, interacting with the arbiter, sending signals and reacting to the managing signals, they would also fence the master if it was isolated. So what is fencing actually? Fencing is actually building a wall for an isolated master, not so that it didn't receive any changes and didn't affect it in any way. In a classical interpretation, it's turning off the whole node, switching off the whole node. That is called stomp, which is literally a headshot to a node. We can also break up the connection to an isolated master, or we can switch it to read-only mode, which is the simplest option. And second type of fails is because arbiter is one point of fail, of crash. So if it crashes, then there is no one to manage the cluster. But such architectures, they do exist, and they are actually workable. As an example, we can give you the solution from the CITES data regarding the failover. And there is a special policy for the fencing for an isolated master. It's being fenced if arbiter is not available and other replicas are not available. So we can check their status using special. I will show you the picture how this master is working. We have two nodes, master and replica. We have a third node, a monitor, and then the primary thing, the leading node is going to be fenced if there is not going to be monitor available, or if the second node is not available. If the monitor is failing, then the whole configuration gets frozen up, and those agents that run master and replicas, they're not going to do anything. And the important thing is to see that in such cluster, only one fail is allowed. If it's more than one, then that's fatal. So I gave you links here where you can read about the failover, about the fencing technology, how does this work. And we want to have a more universal cluster that could withstand more than one crash. And to have that, we must build a cluster using arbiters. But it's not enough to do it highly available. We need to connect arbiter with the protocol consensus because they are making quite important decisions. We need to make these decisions coordinated among all the nodes. And in this scheme, we have some proxies here. Just to balance it out, balance system out, it can connect to arbiter to see where the master is, and then to connect to master directly. And there are such solutions that implement the consensus protocol, ready-made solutions. It's called DCS, Distributed Configuration System, which is distributed configuration system that represents universal IP to some sidecars that allow you to build some solutions around it. It could be consoles, ACD, Zookeeper. These are CDS that are implementing Raft protocol, or Zookeeper. So that's implementation of boxes, actually. All the managing of the cluster is being done by a separate tool, that can impact, change the configuration of the DCS that are stored there. Well, basically we can say that this scheme is the main one to classify the Patroni and Stolon class. The agents for the PostgreSQL, they get connected to this configuration and then they configure Postgres according to it. So let's sum it up. What Patroni and Stolon cluster is. It's an auto-failover. In a cluster, we must always have some active node, and it's also an orchestration device of the database. It's important to know that they also represent a certain automatization of the process around the PostgreSQL. They are also getting integrated with some clouds, for example, Kubernetes, and they also represent so-called database services. And the motivation to use these solutions is if you have too many databases in your corporation, a lot of highly available clusters, and you would like to make the incidents inside these clusters automatic. Also, if there are some demands for the downtime of the clusters, some really strict requirements, and you still want to have some night sleep. And let's now switch to the setting and installation of all the components. Let's start gradually with the DCS. That's the component that is the fundamental one. And it is important to know that as the first thing I mentioned that's a unified distributed point of fail. If, for example, this DCS fails or crashes, then all the nodes, they must stop accepting transactions. They must faint. Why does it happen? It's an interesting question, actually. Because from the node's point of view, those that run Postgres, it's impossible to distinguish from the situation when DCS failed and is not available, or when, for example, when split has happened and they are in a minor part of the cluster. And they must be fenced to prevent split brain. So nodes can distinguish, can tell apart these situations. So any DCS fail can lead to some dire consequences. So DCS itself must be installed to 3 to 5, 7 nodes, at least 3 zones of availability. Why is that? Because its ability is guaranteed by the workability of the majority of the nodes of the cluster. If the net split is happening, then there is going to be the part with the most active DCS node is going to be active. And there is this classic standard raft protocol that is being implemented among the nodes. So let's take a look at it. Well, actually, all the DCS nodes here, they work stably. If they work stably, then they become either leaders or failovers, like in a common PostgreSQL cluster. But the mechanism of the real action of leaders, it is integrated inside the raft protocol. And there is also the third state, candidate state. In this state, the nodes are electing a new leader, and all the logs are going through the node. So if it comes to failover, then it goes further to leader, and then leader distributes it to all the other replicas, and then it gets the quorum of replies from these replicas, responses from these replicas. So we had this delay of 1 or 2 RTTs and at least 1 of sync. Rating can be outdated directly from failover or from the leader, but it's even better if it's going through a quorum, which is going through an actual leader, current leader. And then you can see a couple of other characteristics at the bottom of the page, but we will talk about it later in detail. Let's now switch to practical part. I have these virtual machines ready for you under logrand, and I highlighted 2 network interfaces, 2 bridges. One of them One of them is working bridge, and then the other one we will use only for the connection, the working bridge, working interface. I'm going to experiment with it. So, and the second bridge will allow us to see the results of our experimenting. And I would like to show you already at my virtual machines, I have all the software components are installed already, and I would like to run through quickly this installation process with the rows that we have developed. Sorry, wrong line. Now everything is standard here, so it's a minimal installation. We are just putting binary there, so then we are forwarding it across the machine, the working machine. Then we are configuring the system, so you can see it's located in the relevant paths. So etcd in the folders that we have, and then the services that are starting launching the agent. Let's look at the etcd configuration. So all the parameters that we launch etcd with, I'm using environment variables where I define the IP addresses that we're using to connect for the addition. So we have two instances of this. Listen client is for the client to connect, and the listen peer, this role is for the connection of some other nodes, of external nodes. Then we have two advertised addresses. These addresses, they also must be defined. So they are mentioned in the configuration of the cluster, and via them we are doing this kind of a discovery, sort of a discovery like with the current node. So how can we access current node from the other nodes? And there are two parameters here, hint bit interval and election timeout. So let's launch these services at all the three nodes because we haven't launched them yet, and let's go active with them. We're doing this with this command. I've got a special command prepared to do this. That's it. So I activated the services. Let's take a look at logs of the etcd logs. So that's where it was launched. So I launched the etcd. We see it running. So it has become later at the term too. Well, term is some analog of timelines, something similar to PostgreSQL timelines. When you elect a new leader, there is a bigger term. And this cluster state you can see using a tool, special tool, member list, and we can see that the first node has become a leader, and the others are followers. Allow me to take a look at my notes. So let's now toy around a little bit with this cluster. In particular, we can try to imitate a fail of a leader. So let's see what's going to happen with the rest of the nodes. To do that, I won't switch it off. I won't switch etcd off. I will just stop it. I will just kill it. So let's see the logs of others. Let's look at the reaction of etcd. So you can see here that the second node, so here is it has become a leader at the very next term. If we take a look at the cluster state, Then you can see the second node has become leader. We can also look at the statuses of the nodes using the health check command, if I remember it right.
So it's health cluster. We see that node number 3 is okay, but the second one looks like it's freezed. Okay, we're not going to wait for it. Let's activate it and let's take a look at the logs of ATCD. So you can see that it is trying to connect to other colleagues. Yeah, and it has become a failover, a follower. And now let's take a look at more interesting things. Let's try to isolate leader from other nodes. Let's take a look what will happen. So node number 2 is our leader, and in order to isolate network, I'm going to use a special utility which is called Comcast. It's a wrapper above ADC that allows you to physically experiment with your traffic that goes to your node and from your node. Now, what I'm doing, I will just hide the interface for package receiving and sending. There is a special command, Comcast loss 100%. Now let's take a look at the logs of the second node. So you can see that it cannot connect to node number 2, and then we see that the system is trying to choose the next leader. Maybe it already happened. Yeah, it has become a leader. Okay, let's go back to our timing. So I have mentioned two parameters, election timeout and heartbeat interval. The thing is that from leader, follower gets empty packages, empty entries, just heartbeats, so followers could know that the leader is still alive. And if a follower doesn't receive 100% of this heartbeat or other entry from the leader for a certain timeout, it becomes candidate. And then we select a new leader. These parameters are required if you would like to use special configuration for your cluster. So on the previous slide you could see these parameters by default 100 milliseconds, and if the cluster is located locally, this is enough, but timeout by default is 10 times more. So in our test, I will try to simulate latencies in the network just to test our configuration, and I will do round-trip RTT parameter higher than the external timeout because the timeout is 1 millisecond. In order to do so, I will use Ansible for all nodes, and in particular I will do like this. Comcast device. We are working on the first interface, and then we set delay parameter 600 milliseconds, which is the output traffic, and it will equal 1 second. It will equal to 1 second. So here we go. Let me delete this. So delay is 600 milliseconds. Something wrong. Well, let me try and imitate this over here. Delay 600. Yeah, it's all about latency. That's true. Thank you. Let's try our ping to the second node. So it looks like it got stuck. Maybe I just broke something up. Okay, let me use it one more time. Okay, let me just turn it off, and then I will switch it on again. Oh, it works finally. So, you see that RTT between nodes is more than 1 milliseconds. Let's take a look at logs. So you can see that term is being converting constantly. Looks like nothing changes. We have ping for node number 1. So the behavior in general should be the following. 1 second timeout should take place, and each node should become candidate by increasing the term number every time, and the cluster will degrade completely by that time. So in order to fix this situation, let us change heartbeat interval parameter, and the heartbeat will become 10 seconds. Let me do this. I will do it through Ansible with my playbook. So it's not it. Then etcd config, and now I will set as distinct parameters for each node, so they were the same for across all nodes. Okay, let me see. Let me check my configuration. You wanna zoom in? I don't think it's possible. So is it okay right now? Yeah, okay. I will just export those parameters. Okay, timeout will be 10,000. Looks like that. Here, I have to put my option -e. So EDD will restart. Looks like it takes some time. Okay. Let's see the logs. Okay. So node number 1 has become a follower, and if we take a look at the cluster, so node 3 has become a leader, and the rest have become followers. And the length of a follower will increase in this case, because before the new leader selection will start, 10 seconds should pass at least. Okay, let me put something into etcd just to check the operation's duration. Something very simple, very basic. Let me just put a foobar value into it. Deadline is exceeded, but that's quite okay, that's normal. There are 2 parameters, by the way. You could see them. So this is the timeout itself. Connect timeout, and it will be, let's say, 5 seconds. And ETD will be just 10 seconds. And for testing purposes, the operation duration, we will use get command. It will go through the cluster quorum. So this operation is quite a time-consuming one, and now let's go back to that window. Let's stop our rule, and let's return our parameters back. Heartbeat 100 milliseconds and the timeout 1000 milliseconds. It is to be noted, by the way, that etcd clusters and graph clusters, so some node operability can impact this, so the cluster can degrade in this situation. And let's check this situation. So we have returned our settings. And now we are going to emulate periodic isolation when we are going to put something into cluster. And we will do it through the Comcast script. So we are going to include this interface, and then through sleep, which is 1.5 seconds, we are going to turn it off. So this is stop and sleep. So I forgot about do over here. Now that's okay. I typed it incorrectly. So there is a typo, obviously. So now, let's take a look at our logs of etd. You see that the term is constantly increasing because we are not isolating a node. The term is increasing. We're trying to connect to our cluster. The term has been increased. We do reselection. So this process is like an ongoing process. It lasts forever. And if we, for example, take a look at etd quorum operations, it should be unstable. You see, more than 1 second. Quickly. So this is why it is crucially important to have all nodes operational. And it's not only about network connection, it's also about your drives. Because when you make an f-sync on your drive, the system will freeze. Okay, let me stop it. And so to wrap it up, in my last slide on etd, I have put the key points on the cluster. We have to react not only to network state, but also we have to check whether the drive works stably on the right time. Also, it is crucially important to understand that Heartbeat etd should be maintained and monitored and backupped, and you would probably require special people or even a special team to do it. Also, you can use this cluster for other clusters. So this is how we do in private clouds, in individual clouds. And also, you have to remember one thing, that when split happens, the active part of cluster will find itself where quorum DCS will be located. So you can see it in the picture. You can see the quorum of Postgres on one side and DCS quorum on the other side. So where we have a Postgres quorum, this part is not active. In this image, if you take a closer look, you see that replicas allocated, async replica allocated in a different part, and auto-failover shouldn't happen. In this configuration, cluster will crash, and this is one of the drawbacks when DCS does something like this. Okay, what comes next? Now let's talk about Stolon. So it is built like this. Around DCS we install a couple of Stolon DCL agents. They are arbitrous. They interact with the DCS through literal action mechanism, key support, and their stateless service. Postgres is being managed by Stolon Keeper, and the entire connection to cluster goes through special proxy, Stolon proxy, that can read your config and checks the entire connection.
Если смотреть на физическую инсталляцию,
If we look at the actual installation for the 3 nodes, that's how it's going to look like. At the very least, we are installing Citadel to 2 nodes, so thus we have access amount of it, then Stone proxy for the 2 nodes, and for example, 2 database nodes we have Stone Keeper installed that is managing POSIX instances. Well, let's now take a look at how these installations are performed. I will start the main task. That's a Patroni here. Here we have Stolon. Well, everything is pretty much standard here. So we unpack the binaries. We use the correct path, and then we are taking the configuration file. We're define the variable environment for the Stolon agents. And then we deploy data directory where we are going to have database and SMD services. So they are quite particular here in this instance. I will show you. Then we also have 2 users. One user is super user. He is the administrator, and the second one is just for the sake of replication. And we can also use a special file where we can deploy passwords, access passwords. Let's take a look at the configuration of Stolon. So that's where it exists. I will explain why we call it a test cluster, why we need a name here. I define all the variables of the environment for all the agents. It doesn't matter if it's a Stolon Keeper, Stolon Sentinel, or anything else. For just entry points, so that we could configure them just right here on the spot. And then we are putting path for binaries and for the folders, and that's a basic path here because the dat directory path is the only one that I'm configuring, which interfaces we are listening to. Super user, the one that is going to be on behalf of the Stonekeeper and the other companies, connect to the database, then the replications, users, and so on and so forth, actually. So you can look at the documentation to see what each of these variables actually means. So why do we call it test cluster? So let's take a look at system team. The way it's made, so that it is made as template service, so that we could the install cluster name used as a parameter, and this name is used when we need to find necessary configuration for this very cluster, and that's where we are installing the actual dat directory. Why is it like that? It allows us to use one node to support few Stolon clusters that is managed by one file, by one service. It could be required, for example, if we need to restore our cluster from some backup, and at the same time we want to keep all the configuration, all the parameters and data files at the current node so that we could roll back to the previous version. So let's, for example, put using Ansible, we will launch our services. I will go back to this picture, so I will do exactly the same as it's pictured here. At the first and the second nodes, we're installing Stonekeepers. So we launch it at the first and at the second nodes. So let's start. Let's get it going. Let's take a look at the logs now. You can see that it started, it was launched, then it found its dat directory, and now it's waiting for the cluster configuration. We should say here that each component, Stonekeeper, Sentinel, and Proxy, they can be started independently, so they are not going to break anything. So let's use node 1 and 3 to launch to run Sentinel. Now let's take a look at the logs. So that's what we launched at the first node. We can see that it wanted to get leadership through this yes, but it didn't get the leadership, so the third node has become a leader. Now let's take a look at that node then. I'm gonna do this. So here is it. Here it is. The node 3 Sentinel at the node 3 has become leader, and now we have a backup Sentinel at node 1. And now we can install to all of the nodes now. Proxy. It didn't start somehow. I wonder why. Let's see. Let's take a look. Again. Yep. Yes, I'm rushing things a little bit. I'm in a hurry. You're right. Thank you. So it has started, and it's an important thing to know that they all were launched, and now they are waiting for something, and they are waiting for the configuration of the entire cluster. So let's go back to our presentation. So there is the workflow of the Stolon cluster. The databases are initialized in the whole cluster using a separate command. All the changes for all the parameters is being done also externally using an update command. And another thing that is important to note is how Postgres is restarted. For example, using a special parameter, a special command. You can do it manually, for example, by restarting a keeper, or you can just finish the postmaster, and then the keeper will restart the PostgreSQL. In the new versions, there is a special parameter, automatic automatically restart that allows to restart the system automatically. Postgres knows automatically when they have upgrade parameters, but we should note that the order of restart is not right when the special parameters are changed. For example, the max connections, max log per transactions, so they require a certain order of things to restart the nodes. And when this parameter was released, they didn't use this problem. They didn't approach this program, and there is a risk to lose the parameter forever if we are making this certain parameter smaller. If we are increasing it, then the next restart of the replica, then it will bring back the node to the normal conditions. So be careful while doing this. And adding nodes, just it's a launch of Stonekeeper, and the deletion is when we stop Stonekeeper, and then we see the node as failed, and then using a separate command, we can delete it from cluster, actually, with cleaning up all the resources it had taken. So let's do the following thing. I will show you how to update Haba. So you can see in our catalog the clusters that we've chosen. We didn't initialize all the clusters, so let's do this. And I've got a special file that I've prepared before the demonstration with the Stolon test cluster spec. That's where we define the specifications, all the parameters for the new cluster, and how it is going to be initialized. So let's go back to representation. Stolon has 3 modes of initialization. The first one is from scratch, when we are starting MDB, then using the point of recovery from a backup, and also we can use it to install a so-called standby cluster. And there is a link at the bottom of the page, so if you're interested, you can read it in more detail. And there is also a third mode, auxiliary mode, that allows you to install cluster if we have lost the DCS data. If you're losing the DCS data, then cluster just can't function any further. You will need to reinitialize it, but not to go through NTB again, not to lose all the data. We can use the option of existing initialization. So I'm doing the initialization from scratch, then I'm using the option for existing, so all the parameters, sync of replication, and then let's do this. Let's see how it works. And then I'm sending the configuration file to the entry point. So let's take a look at the log keeper, for example. So we have changed the log that we have. The keeper is waiting for its role that is being defined by the arbiter's sentinel, and it's trying to apply those. Well, so that's what I did. It sorted out the database, and this instance is in standby mode. So it has got the standby role. Now let's take a look at the state of the cluster. There is a special comment, status. It allows us to see that. So here you can see what are the keepers that we have, the host check for the keepers and for the Postgres that are being run by them. So who's master, who are replicas, active proxies, and sentinels. So it doesn't contain a lot of information for sentinels and proxies, but well, that's what it is. An important thing to note here is 2 fields. We should say here that stonekeepers work according to the following principle. From the Sentinel arbiters, they get specs where the node role is defined, its parameters are defined, and the keeper is also monitoring its own condition, its own state, and it should put its state into state that would correspond to the specification. And you can actually take a look at the definitions and the values of all these specifications. So it's a large file. We're going to break it down. Here we go. Here we have the general cluster information. These are the specification, its specifications. Then we've got information for each keeper, about each keeper, and about each database. So there is a special field that's responsible for what the current node should strive for, should look like, and its current status. So what it is now, actually. And so on and so forth. Mostly you can use it just to monitor things, to break the information. You can also get this data using the etcd keys. And now we move on. So now look. By and large, we can do the following. We can switch off, we can stop the etcd just out of interest. But we should mention here that all the agents they can connect to each of the etcd nodes as one is stopped, then they connect to a different one. But it's not being done in console. In console, we can only connect to one node, to one agent, and then if it crashes, then the agent, for example, the Stonekeeper, is out of cluster. If we kill Postgres, if we stop Postgres, then Stolon will restart it. And if we kill Stonekeeper, then so it's in the restart mode. In system D, there is an option on a board, and so we should use this option. But just out of interest, let's try to kill Postgres, and then let's do kill 9. You will see that it will restart. So let's use master to do that. So master is node 2 now. So let's kill it. And then let's take a look at the logs. So it has started. So now we can backtrack a little bit. So that's where we killed Postgres, and Stonekeeper restarted it. So it is a kind of a supervisor of Postgres in this way. And the rows in the cluster, they haven't changed. So let's now do something more interesting. Let's try to model the real file, actual file, and let's stop master, and let's keep the external workload in this very master. So I will emulate this workload using this command. What? Can we try to delete some file that is responsible for a page in Postgres so that we could corrupt the whole block of and then we will get the error that the block is corrupted and we can use. If the block is corrupted and we are using the checksum to see it, we will understand that the checksum doesn't correspond, then the operation will stop. It will, and then we will get it in the log that it's corrupted. And if checksums are not enabled, then we can find some error there still. But then Postgres will tell you about it. It has nothing to do with Stolon. The Patroni and Stolon, it has nothing to do with this software. So allow me to start the PG bench. I think I has prepared it for the demonstration. I will initialize the database. PG bench, so I will connect to proxy. That will reroute the connection to the master. I have the port 2542. 2542. I think it's no, it's 2 and 3. So let's take away this parameter. Yes, I've forgotten one thing. My base now we have installed 2 roles, so let's take a look at those. All the PG data is stored at the Postgres folder, and let's look at the HBA. So you can see it here that the Stolon by default has recorded only the super user data that connects to the database, and it's used for the replication. I would like to add the third user that I'm going to use as the workload for the system. So let's look at the specification first. There is a defaults option that shows us everything, all the by default parameters, and we need to change the HBA option, PG HBA option. So I'm running the update command. And here I'm initializing all the lines of HBA for connection. Let's open the local one. So this is the Postgres user. And also for all the current nodes of this particular network. So 0, 24, trust. So let's define it, and we will assess now how these settings worked. They haven't been applied yet, so now yes, we have them. So allow me to enter the database, allow me to create the Postgres user.
Так, зайду локально. Так, от Столона. Так, local. Postgres. О, так от.
So here we go. So create user. Postgres and super user. Oops. Okay, let's do it differently. Okay, we've got Postgres, and in general we can finally connect. We can finally initialize PGBench. User test. So tests were made for Patroni. So the database has been initialized, and now let me put some load. We type Postgres. So I've got 20 minutes left. Let me stop those experiments for a while. I will just briefly cover them up, and then we will continue, if you don't mind, because it takes me too long to set things up. I'm a little bit nervous, but still. Let's talk about time characteristics. So we've got 3 parameters: sleep interval. It's when each component is triggered. Request timeout, deadline of operations to PostgreSQL, deadline to DCS is hard-coded to 5 seconds, and fail interval when node crashes. Sentinel takes this event, captures this event, but failover doesn't start immediately. It will start after this fail interval, just to make sure that the node is really out of order, out of service. But also you have to take into account that if a node is not either dead or alive, this fail interval will start from the beginning. So how it happens? How failover happens in a Stolon cluster? Stage number 1. You have to identify a crash. Stonekeeper can mark Postgres, and this information goes to Sentinels, or the status is no longer updated. A Sentinel can capture this information too. For example, the configuration is frozen, its status is frozen, to be more correctly. And this stage lasts up to 10 seconds, so 2 times of sleep interval value. Second stage, timeout confirmation is launched. As I said, it is done on Sentinel. We just check that the keeper that has been crashed is really dead, and then a new failover configuration cluster is activated, and then it is populated, it is distributed across all the keepers. And this stage lasts 2 sleep interval cycles. So here you've got some data for LAN 2, LAN 3. So, but it depends on the situation. And last but not least, after promote of a new master, we change to a different replica. We switch to a different replica, and this information is captured by DCS too, and then through Sentinel, this information goes to proxy. It captures this information, and then the reconnection is being executed. And to sum this up, if DCS is more or less stable and Sentinel leader has not been changed, failover will last from 25 to 50 seconds. If Sentinel failover happens too, so the failover will go through Sentinel. Sentinel will be activated. It will be active, and all the stages will be reactivated from the scratch. It is to be noted, by the way, that if Stolon proxy and Keeper will be isolated, Keeper will not convert it into read-only mode. It will not affect Postgres. So these operations will be done by Sentinel proxy, and a very interesting function is implemented in it. If it cannot connect to DCS, it means it is isolated and it has to block all its connections. Otherwise, it could write to master without any restrictions. And some final touches, let's say. One positive thing to mention, Stolon is being managed very efficiently with replication slots. When you delete a node from the cluster, or when it is crashed, its replication slot and all the writes will not be deleted immediately. So there is a special timer that is triggered, and it is defined by keep a remote interval. And if the node doesn't respond, the replication slot will be deleted, and the writes, the entries will be deleted too. Also, you can delete a node manually just to avoid wasting your time, but you have to understand, if you keep replication slot on master and replica is not active, master will accumulate data and the data will not rotate. 48 hours is just too large interval for high-load database. It is to be mentioned too that Stolon is trying to automate as many things as possible. Sometimes it's not good. For example, it has special timeouts and deadlines for some long-lasting processes inside the Postgres. For example, DB wait and DB timeout set the deadline for process recovery at the database start 60 seconds by default. If checkpoints are distributed at a distance, this deadline is just too optimistic. Sync timeout is even more interesting because this is the deadline on database recovery. 30 minutes by default. If you have 1 terabyte database, it can take up to several hours to recover your database. And this parameter will be disabled starting from new version. And init timeout is the deadline on database initialization. Also, it is not written here, but it is called convergency timeout. As I said, Keeper is trying to match its state to specs, and they have their own timeouts, by the way. So when you're using Stolon cluster, you have to bear this in mind. If one process doesn't meet the timeout, Stolon will reactivate it. Now let's talk about Patroni cluster. In the beginning, I showed you the general schema, but I wasn't quite. It wasn't quite true, because there is no special arbiter component. Because we have this for Patroni agents. So, what about different Patroni agents? So you can see this in the slide. First, let's talk about cluster arbitrage. So we have time to live support, and on the other hand, this allows in stateless system to choose a current leader, a leading process that will make some critical operations. But this applies to stateless services. Patroni just complements this paradigm by introducing a special stage when you're electing a leader through well exchange through REST API just to understand what node should become a master. And a node with the biggest well will become a master eventually. So this is it. And classic 3 nodes installation will look like this. We've got ECD cluster as a proxy. In Postgres Pro we have recommended this type of connection that can be implemented into this cluster and get its configuration. Patroni itself, while being initialized, allows us not just to initialize the database from scratch, but also to define customized replica restorations. In Stolon, this situation is hard-coded, and replicas can be obtained through replicas, and in Patroni you can define them separately, stage by stage. You can do it, for example, from backups. Also, you can use customized options for backups. You can use it, for example, if you want to restore table space. And a typical workflow when you work with Postgres cluster will look like this. We launch a node with the section where it is defined how cluster is going to be installed. Then we launch all agents. They're waiting for the configuration, and then through init we initialize the cluster. So then we just bootstrap, and this node will initialize everything. What is good about Patroni? PostgreSQL.Conf and PGConf can be updated globally in the DCS section, just like we do it in Stolon, or you can use it locally for each single node. And local nodes overwhelm global nodes. So we have special commands on nodes, restart, and the launch, Patroni. Now let's talk about proxy, because it's a third-party component, so the variety, your options are quite wide. You can use different combinations. Each Patroni agent just exposes a REST API that can be used to check that the node acts like master or like replica. And as a standard, you get config proxy config, that contains information on Patroni agent. Also in Patroni you can see callbacks, but they are being launched asynchronously. You can use them in order to check your proxy configuration. What we recommend to use HA proxy combination with components that can change our HA proxy configuration based on this information. So we also have etcd template and the rest of these templates, and you can also use custom or manual operation. Starting from this Postgres version, there is an option to enumerate several hosts and to use special parameter which is called special attribute. So the client will just go through all hosts one by one and to check whether host corresponds to the condition defined in the target session address, and it should be master. In DeepC, this option was there before, but in general we do not recommend to do so, given that Watchdog is configured and fencing is not implemented. So when Postgres is not isolated, if for example we switch off or kill or just hook a Patroni agent, why? Because in this case Postgres is just no longer controlled, no one can manage it, and it will not be able to get connections from agents to make right operations. I was trying to simulate this operation, but unfortunately I failed to do so. We can do it after the presentation if you're interested in. Well, about weak points, about Patroni and Stolon, that node fencing depends on agent capabilities. We can do anything on agents and the node will not be isolated. So maybe Pacemaker with the obvious channel is the key. You can also get information whether our master is a master through DNS server. We can register services and attribute them to domain names, but you have to use DNS configuration. Well, but it's not a typical operation. And also a few words to virtual IP address. You can do it through HA proxy or keep manager, where agents are subscribed to DCS, and then you deploy virtual address in the place where you've got master. But we're not recommending to do this in Postgres Pro, because you can face a situation with the two virtual IP addresses. For example, if we do keep alive and we have IP address on a different HA proxy, we will have two active IP addresses on two nodes, which is not good. If we freeze agent of master, we will make a failover, switch over, and no one will release our IP. We will not be able to get it. So it's better when we just physically kill a node, like it is done in Pacemaker. Also, I wanted to say a few words about auto-failover. We've got the same, the following parameter: TTL, life of the key, loop wait, retry timeout, and master start timeout. And in the bottom you can see a formula that you have to follow just to avoid fake failovers. The essence is that when you update a leader key, Patroni agent calls for Postgres, it calls for DCS, moreover it waits for the timeout. It is important that the key lifecycle stands within all these events time. So how failover works in Patroni? So the node disappears and DCS keys disappear. Other agents get a notification, and it takes from 20 to 30 seconds by default, according to the formula. Then Patroni agents start changing information among themselves using REST API for endpoint of Patroni, and the timeout for these changes is 2 seconds. If it does not respond within 2 seconds, it means it's not available for a moment. And among the nodes, we choose one with the biggest wall position. Then they are just rushing for the leader key through DCS. It's just a swap operation, and some of them get this leader key.
Ну, а дальше, собственно,
Well, and what happens next? All the clients will have to reconnect to the new master. Well, in total, if we are using by default settings and DCS is stable, then it takes about half a minute. On the condition that all the proxies are getting reconnected in 5 seconds. So now I would like to talk a little about this. I would like to imitate this situation with fencing when we have clients. When the client connection is done not via proxies but via a number of hosts. Here we can see the situation where we kill or we put to sleep a Patroni agent, and we're using the former master to connect the two, and here I have listed all the options to bypass the situation. You can use the synchronized replication, but you do that, you gotta understand that even using a synchronized replication, you need to make a local commit or finishing the queries or even the commit. Then you need to do it properly, because even under the synchronized replication, the Postgres will send the backup, the wall commit to its disk, and then it will be waiting for the responses. What Zalando offers, that's setting of the watchdog. So if Patroni doesn't respond to after a certain amount of time, the whole node is getting fenced. It's either restarted or it's stopped. So what we offer to our customers is bypassing the situation using hub proxy and confd that would reconnect to the master unit. That what we are using, what we are offering. So using the master node, so if it's getting promoted, so first we are switching off the node 2, we are guaranteeing that we're not going to have the second master, and only after that we promote the node. So that's the picture, the scheme, how it's going to work with the hub proxy. And what's going to happen if we are going to have NetSplit, then hub proxy and Patroni, they will become isolated. And this link is going to kill all the connection to the former master, to the previous master. And then we'll use the health check at the Patroni agent, that's how it kills it. But there's also the Consim thing. It will freeze the configuration if it becomes isolated from the DCS cluster. And it could lead to some bad situation if you are using Piggy Bouncy instead of hub proxy, because they don't have the fencing logic in case of isolation from DCS. The configuration gets frozen and all the connections, they can still be sent to our master that is not demoted because Patroni is not working on this occasion. And the final touches, final strokes. I will explain what are the weaknesses of Patroni. It doesn't work well with slots. The thing is, when a node disappears after a certain timeout, it deletes the records, the logs from the DCS node, and then it deletes the replication slot. If the node has on downtime for a lot of time, then it goes back to cluster, then there is the chance that it won't connect to the master again. And to bypass this situation, you need to set the parameters for the certain sequence or to backup the whole thing from the archives. And with the synchronized replication, the only one response will become synchronized. So we don't have this quorum thing going on because of that. The support of the quorum out of the number of synchronized responses. If there are too many nodes and there is a synchronized replication going on, is running, and then the master and synchronized replica are going to be isolated from the main cluster, then there is not going to be a failover. So all the other replicas will be synchronized. And the good thing about Patroni in comparison Stolon, so it supports a lot of important enterprise features, especially enterprise version of the software, restoration of replicas from the backup, so it's very relevant for the large bases. So it's also not strict synchronized mode, so master can switch to asynchronized mode and then it could still receive the records. So if this master is gone, there is no failover until a certain replica is not going to be synchronized with the master. And analogous, you can see here, max availability in Oracle Data Guard and more flexible settings in comparison with Stolon. So thank you for your attention. Maybe you have some questions. If anyone has any questions, then please raise your hand. I've got a question. So you've been telling about it, TCD, about the requirements of the disk. So I just wonder, do you have any experience? Yes, I do. We have deployed not the TCD, but a console in the mail cloud. And the instability for the F-Sync operations per disk and the high quantities led to degradation of the cluster. Are there any specific requirements? Because there is a picture there you had that one host has both. The way I understand it, that you need different mounting points, because as soon as Postgres starts reconnecting, it loads the disk a lot. And if there's going to be DCS, then it will become unavailable. I agree with that. I agree. So if you have any, I don't know, some settings, or you could share your experience on how you did that. I tried it too, and the console is less demanding to all the isolation things, and a TCD is just, it needs a really good disk, a highly available disk. Can you tell a little bit about that? I wouldn't really tell apart console and a TCD because you're using the same algorithm wrapped. Both systems are making F-Sync when they're writing to the disk. As for breaking apart the storage for Postgres and DCS to different disks, yes, it could be an option. We don't really recommend doing that. Our users or clients, it's up to them, so that's not our recommendation. I see, thank you. Here to the left, can you tell about Zookeeper? Have you tried it? Other listing for Patroni, and what about it? Not Zookeeper, I didn't support it, I didn't work with it. Mostly it's about TCD clusters. Thank you. So it's not supported in Stolon, but it's supported by Patroni. On the right here, on the right hand, on the left hand side from you. The question is, the question that I've got, are there any recommendations on how to use slots in Patroni exactly? Because you've talked about this problem that it deletes the slots and there is nothing how to control this kind of behavior. So can we avoid having this problem? No, not with slots. So it's either you should use the segments by keeping a special amount of segments per master, or using archive, using the backup options. And recently I've seen in the issues, so people were complaining about this peculiarity of Patroni. Maybe in the future they will fix it and they would do something that Stolon has. so that they delete it only if the user expressly asks about it, requests it. Thank you for the report. So I'm sorry for bad time management, so I didn't have enough time to have all the experiments. Thank you for your workshop. I could add a comment regarding the replication slots in Patroni. There is the chance to create your custom-made permanent slots. So if you have created it, then it will stay within the cluster. But these slots, they are for different clients. There are special slots for replicas, so they are not for the same purposes. Thank you very much for the comment. I haven't used it for replicas, but that's the way I understood. Maybe I'm wrong, but mostly, well, me personally, I'm solving this problem by increasing the amount of the wall segments, you keeping in mind the workload for each cluster individually, so that if the replica is not available, it could get these walls. Usually it works, so it wasn't something urgent, so probably I need still to check it, but it worked with my system. I could add a little bit about the slots. I forgot to mention that initially the slots, they were developed for the fixed configuration of the master and replica, and they are not adapted if the master is external. So to say, when we're doing switchover or failover, we must create the new replica slots for the new master. And when it happens, when we promote, there are the checkpoints, and we can lose walls. And replicas, probably they wouldn't work under the new master. So it is a well-known problem. I know that hackers know about this problem, and hopefully in the future it will be fixed. Thank you for your presentation. The question is, so you have researched all the areas of this technology, so you have exploited, you have used certain things. So from your point of view, what are the most reliable and the most promising for the near future for the development? So which software is going to be developed better? So if you want to answer right here and right now, then I'm for Patroni. Even I am one of the developers for Stolon. I think Stolon can be really brought to top shape, so I like the architecture that is used there, because it's exactly a copy of the cluster Kubernetes, where we have the leading services for the cluster and some services that work with the nodes, Keeper and Sentinel. And in this way, I think that this product, if you worked really well on this, it has more potential. And as for Patroni, I can just tell you privately, there is one weakness when you appoint a new master, because when you are changing the wall positions, when they're choosing the node with the biggest wall value, then it's not done by DCS. DCS is not aware of this thing happening, and we faced this problem and we fixed it later when a node was isolated from DCS, but at the same time it was part of the leader election, and it was standing in the way to appoint this new leader. I can even send you the issue, so it's going to be a console thing. So this mechanism has not really worked properly in Patroni, but in Stolon they did it by the book, so they just copied it from the better analog. And another question, so you said a good thing that you are one of the developers of Stolon, so you're developing Stolon. So look, I had this, I had a task, we had a database, a master-slave database, and we needed to use it with Stolon. Now, it's not going to work only if you're going to use a standard cluster. So in Tutu, I have an option to use the Stolon items that would work with the current basis, but for the time being, it's impossible. Yes, that's what I faced when I tried to do this. Yes, I found one way, because there is this Manually, you mean? Yes, if I do it manually, but just be really careful. Yes, that's the problem, because it is so automated that if you're making one line mistake when you're trying to connect back and forth, and then it will just steal all the data, and then it will create just a new empty slot. So it's not fixed yet. No, it's not. And in Patroni, actually, so it's doing better in this relation. So you can switch it off, you can add the new database, it will see the new data and will start to work with the new data. So, okay, well, thank you though. Well, the catalog for Patroni, it must be identified clearly and it shouldn't be deleted. And Stolon, they decided to use the cyber data to work with it, to manipulate it more easily. And could you say when are you going to implement this in Stolon to fix this in Stolon? So it's an open source, so maybe someone will do it, but they have the understanding that it's a necessary thing. Yes, we had an issue, we were recommended to fix this. So, and I was one of those who thought about this. Yes, I remember there was a chat room somewhere, and a lot of people were asking this question, and they are not getting any answers. And then I knew that that was a problem. You can look at the issues. We have an author who wrote about how to do it manually, but maybe, so it's a dangerous thing, that's right. Two short questions, hello? The first one, you have mentioned that there is a problem with the hub proxy when we've got the node list in the application using commas like a list. So then the applications could stay at the old master. And a proxy, there is option shutdown sessions that should shut down all the sessions after this particular node is not a master anymore. How can you say if it's a master or not? Using the hub checks? Yes, HTTP checks. I think I've mentioned the hub proxy doing this. There was this case when we are putting down a number of IP addresses with this connection. And the second option is PD bouncer that doesn't have any health checks. Yes, hub proxy health checks there allow us to fence the current node when it stops being a master. But you know, the better solution is not to base on the opinion of the node, on the opinion of Patroni, because you can put it to sleep or doing something. But they take it from etcd. Yes, to do it via etcd and to fence it, there is no connection. And if we can't connect then to etcd, then you also said that there is a problem when an agent is unavailable and it's not being fenced. So this HDOC that is supported by Patroni, it should fix this problem. If the agent can't update the key, then the watchdog timer runs out and it reboots. Yeah, well, watchdog is the it's a reliable fencing tool, but the problem with watchdog, one of the slides I wrote it, but I didn't talk about it. In case with Patroni, you must appoint PostgreSQL that is going to be managed by Patroni. And watchdog, as you know, it's something that is accessible to everyone, so it can be used by other applications, and we are setting this restriction there. So in this way, we are not really basing our decisions on it. And you know, watchdog, it's working with timeout. For example, if Patroni agent is frozen, just harmlessly, but still the node is going to be rebooted because of that. So the fencing problem of such an isolated node, we are doing it using a smart proxy. But watchdog is starting to work when we are moving to a new master, because if agent is frozen, then still there is going to be failover because it will not be able to update a key. If the agent is frozen, then in any case there will be, if it comes to fencing via watchdog, then the master will change anyhow. Of course the master will change, but will we demote the old master under this technology? That's the question. It will either demote or it will be demoted if we will stop Patroni, if we kill Patroni or there's something else to Patroni. But Watchdog, that's right, so it's going to be a defense. Then if Patroni can update the information in the TCD that yes, I'm not a leader anymore, then it's going to be switched into standby mode. If it doesn't do this, then the time will run out, and then everything will run out for this node. That's true, but the main thing here is that we are putting Patroni to sleep not to have this demotion, so to keep it at the same state where it was before. But I understood, I got your idea, so there are two options, either Watchdog or Smart Proxy. Thank you. No more questions? No, there is one more question about the unstable node and the TCD, so that it could lead us to the demotion of the whole cluster. Can we do anything about it? To increase timeouts, so the only thing, or the increase of the nodes, it won't help. The only server can put down the whole cluster. Yes, I've mentioned it on one of the slides. It was number 2. For the geo-distributed and unstable configuration, yes, timeouts are the only way. Action timeout, heartbeat timeout. Thank you.